Today we are going to learn that how we could deal with this function. You already know that we must have the same base in order to operate the logarithmic function. Here the bases are not same. Here I have 3 as my base and again 243 as my base. So you need to think, can we write 243 as 3 exponent something? Because there is a rule. Let me tell you this rule. If there is a log, and suppose if there is a base a, and suppose it has exponent called n, and suppose there is an input which is y, and suppose its base is m. So if both has the exponent, like the input also has the exponent, the base also has the exponent, so they come outside, they come over here and they become the fraction. That means I could write m upon n, and I could write log a y. This is the formula I'm supposed to use in this question particularly. So first of all, I'm just going to solve separately for this. 243, how you can write? If you don't know how to write 243, you can prime factorize. So you can write 243. You can prime factorize by 3, you can go. 81 will come. Again by 3, 27 is going to come. Again by 3, 9 is going to come. Again by 3, 3 is going to come. Again by 3, 1 is going to come. So 1, 2, 3, 4, 5. 243 can be written as 3 exponent 5, and there is x exponent 5. Let us apply the rule which I taught you over here. So what was the rule? The rule was, here we have 5, here also we have 5. So here this is like m and n. I already told you that they will become the fraction and will come outside. So this 5 will become the numerator, this 5 will become denominator. So you are going to write 5 upon 5, and log, you are just going to write x and you are going to write 3. Now, like there is no more exponent over there, and now you can easily solve them. You already know 5 upon 5 will make 1. So what we have, basically we have x and base is 3. This is what we are left with. So I'm going to write that. You already know that we are going to switch the constant to the other side, because constant we are not keeping along with the log. So here we have a constant 3. I could subtract 3 from both the side. What I could write for this, I could write log. I'm writing this function right now. Again, how I could write this thing, I have already written over here. So this thing can be written like this, isn't it, right? And is equal to -3. No doubt. Now here, the logs are in addition. The addition changes into multiplication. I could write log 3. I can multiply x and x. That will become x square is equal to -3. Now what I need to do, let me rub this step. What I need to do for this, the next step, what I can do, I could write, I could change into the exponent, right? So how to change into the exponent? I will write my base. The input will become my output, and this output will become my input, which will turn into the exponent. Now I cannot deal with negative exponent. In order to make it positive, I need to reciprocate my exponent. These are very basic rules. I think you might have learned in grade 6th or 7th, right? So you are going to deal like that, and you are going to do x square like that, no doubt. Now that will make 1 upon 27 is equal to x square. Perfect. Now what we are going to do, now we are going to find x. So x will be, now this square will go to the other side, this will root. So root 1 upon 27, positive negative root 1 upon 27. So, x cannot be negative because negative inputs are not allowed. So only positive part we are going to deal with. Now let us try to understand. Root 1 is just going to become 1, and this will become root 27. Now we can oversimplify root 27 if you wish. Now 27 can be written as 3 times 3 times 3. 3 has a pair. So this 3 will come outside. Right. You already know this. You might have learned in radical and exponent in grade 7th that if there are the pairs in the square root, that become just one number and just come outside. So I could write 27 as 3 root 3, because 1 3 would be left because it has no pair at all. Now you know how to rationalize. We do not keep irrational number in denominator. So better to rationalize, multiply by root 3 at both the places. So 1 time root 3 will become root 3. Now root 3 times root 3, will become 3. This is the rule. If we have root a time root a, so the answer is just a. So root 3 times root 3 is just 3. There is 3 outside. 3 times 3 will make 9. And this can be your final answer. Otherwise, if you write this answer also, this is also not incorrect. This is also correct. Okay. Or otherwise, you can rationalize from here itself. If you have 1 upon root 27, multiply by root 27, here also by root 27, right? So same thing you are going to come, like you are going to come with. So this would be your answer. I hope you liked the solution. If you liked the solution, do not forget to subscribe my channel. If you want to join one-to-one tutoring, and if you're from California, I have a lot of students from California, and our platform is, very specialized in the Californian curriculum. So you can join my platform for one-to-one tutoring. There are many talented and qualified teachers. So the description box contains the website and the contact details. So thank you so much. Have a great day ahead.